will fundamentally change the way ground troops fight guerrilla insurgencies.
Suddenly we have the ability to take into battle things we would not have taken before because they were just too heavy. Suddenly we can take large ladders, heavy artillery, heavy weapons that we wouldn't otherwise have taken.
Big Dog's powerful muscles are hydraulic actuators which contain sensors to measure joint angles and how hard the actuators are pushing. For balance, the robot has a gyroscope that mimics the sensory receptions in our inner ear. A computer monitors all of the sensors to figure out how to give the robot its footing on rough terrain.
When the robot's climbing in the mud, it has abilities to sense that it is slipping on the terrain, and then it adjusts how much load it puts on each leg in order to keep its traction and its balance and its forward motion.
Big Dog is really sort of cool or slightly creepy sort of robot. I think a lot of people have seen it move and are astonished by it.
Perhaps most astonishing are the frenzied autonomous movements the robot makes when it loses its footing.
It has some really fascinating capacity to recover from slipping or being struck. And the way it scrambles its legs around, the way it recovers from being knocked almost completely over, is spookily biological.
The behavior of Big Dog over the last few years has come a long way, but there's no sign that we're really at the limit.
As Big Dog's ground capabilities continued to expand, DARPA started another project in 2004 to explore the next skill for a real Terminator, the ability to climb. One of the scientists they've tapped to bring this vision to life is Mark Kutkoski.
DARPA has a program to try to develop climbing robots for various applications, surveillance, inspection, and so on. I'm Professor Mark Kutkoski at Stanford University, and my goal is to build robots that can go anywhere. One of the advantages of climbing robots is surveillance, spying, or monitoring areas, because they can climb a building or a tree or another structure.
The ability that we required was for the ability for a robot to walk up a vertical surface and achieve a position high up in a tree or up a telephone pole or up a wall.
To achieve this daunting goal, Kutkoski worked closely with biologists to unlock the mysteries of nature's best climbers.
We've been collaborating with Professor Robert Full at UC Berkeley for a number of years.
Dr. Full shot slow-mo videos and microscopic photos of insects to find out how they used tiny spines on their feet to climb vertical walls. Applying Full's discoveries, Kutkoski set out to develop the feet for a climbing robot named Rise.
Here you can see how the spines are grabbing little bumps and pits on the surface, and we have lots of these tiny spines, so they share the load.
The real hard problem came down to how do you achieve the attachment forces between the foot and the vertical surface that's great enough to support the weight of the vehicle itself.
If you want a robot that climbs vertical surfaces, smooth, rough, dirty, clean, then the gecko really is the premier example of a climbing animal.
The gecko can cling to glass by a single toe and walk upside down on the ceiling. It sticks to the surface through a phenomenon called van der Waals forces.
Van der Waals forces are a basic molecular attraction that always exists between any two molecules if they get close enough. And it has to do with a kind of momentary arrangement of the electrons. And you can take advantage of it if you can get really intimate contact between two different surfaces.
Millions of tiny hairs on the gecko's toes create the intimate contact with a climbing surface that generates van der Waals forces. Kutkoski and his team have built a droid called StickyBot that harnesses that same power.
It is basically our attempt to take the principles that we've learned from how geckos climb and apply those to a robot that also uses van der Waals force to climb vertical surfaces. The secret to StickyBot is in the adhesive pads that are on its toes.
Kutkoski's team fabricated pads that have hundreds of nanoscale stalks. As with the gecko, the stalks are sharply angled, so the toes stick when going in one direction, but easily peel off when pulled the other way.
When you load it with gravity, the way the robot loads it, it sticks. And to make it detach, you just have to pull it a little bit in the opposite direction and it pops right off.
Now imagine troops of real Terminators climbing up the side of a building, spying on the enemy, and waiting for that moment to attack.
Once a robot climbs up there, it can hang. It doesn't have to expend any power, so it can cling there for hours or even days, unobtrusively. That's quite different from something like a small helicopter, which always has to expend a lot of power and make a lot of noise.
What's even more scary is not what these robots can do physically, but what they will be able to do mentally. Trusting robots with lethal decision-making will require a leap in technology. For now, the military is focused on making human soldiers stronger, like a kind of cyborg. They would be deadly, but unlike Terminators in the iconic films, wouldn't decide mankind's fate in a nanosecond.
When I first saw the original Terminator movie back in 1984, I was completely taken with it, as I think most people were. I'm Michael Ferris, a screenwriter on Terminator 3 and 4. Just the whole idea of a unstoppable killing machine is so riveting. I think the Terminator movies have really spoken to an innate fear that we have of technology run amok in general.
DARPA has recruited scientists at the robotics firm Berkeley Bionics to re-engineer the foot soldier and give it superhuman strength. The revolutionary result is the Hulk, a robotic exoskeleton for the human body.
The Hulk, or Human Universal Load Carrier, is what it stands for. It's essentially a wearable robot. It takes a load from a person that would be carried in a backpack or in a vest, and it brings that load down to the ground through the exoskeleton structure and to the exoskeleton feet without going through the person. The exoskeleton can help a soldier carry more and new equipment into the field. So things that they haven't been able to do in the past, like, for instance, a single soldier mortar team, a single soldier machine gun crew. These weapons now are carried by multiple soldiers. They could essentially be carried by a single soldier with a device like this.
Since the wearer barely feels the load, he doesn't burn a lot of energy, so he can hike great distances with minimal effort. Here he's carrying 100 pounds and barely breaking a sweat.
Sometimes it's considered a force multiplier in a sense, because exoskeletons can make each soldier be able to carry more and carry it further, so you could actually fight the same conflict with less soldiers potentially if you had the devices.
An onboard microcomputer enables the exoskeleton to mirror the wearer's movements. Just how the Hulk senses a person's intended movements is secret, but lead mechanical designer Russ Angold can reveal where the Hulk gets its muscle.
The Hulk has a computer system on board. This is the GUI right here. I can feed it some information about how much I weigh, the payload I'm carrying, and through that I put those inputs in. The machine has sensors in the feet that sense what I'm doing, and then there's sensors throughout the machine. So when I do moves, it reacts to those moves. So I don't have to do any other inputs once I've put in those initial settings. It's a totally reactive control scheme. So whatever I do, it reacts instantly to that move. I just do what I want to do and the exo reacts. Preliminary tests show we can reduce oxygen consumption up to 15%. The more we can reduce oxygen consumption while wearing the device, the less tired the user's going to get, the farther they'll be able to go, and the fresher they'll be when they get to where they're going.
The plan is that they should be able to, for example, pick up 200-pound weights hundreds of times and not even be able to notice it. They would be able to march all day and yet exercise very little of their own muscle power to do it.
Another project funded by DARPA builds on that technology and takes it to the next level. A robot with a skeletal structure of a human, only with bones made of